Good evening, everybody. Welcome to Science Access. Today I'll be diving on the concept of limits. If you are new to this channel, kindly like and press the notification button so that you get notified whenever we post new videos. Today I'll be teaching you the introductory part of limits. So the definition, when we hear the word limit, what should come to our mind are limits are values when the function approaches at the substance gets closer and closer to a particular value. The limits, as I said earlier, they are values when the function f of x gets closer and closer to a particular value, which is t. T here denotes real numbers, either 1, 2, 3, depends on the question given to you. Now, example to expatiate or tell you more about limits. I told you limits are value when the function here is f of x gets closer and closer to a particular value. The question here denotes as x approaches to function f of x approaches t. T is the case study here. Now, limit f of x equals x all over x squared plus 1 as x approaches to. Now, we use direct substitution. Imagine that there are different methods of solving limits. 1, we have the direct substitution method. 2, we have the factorization method. 3, we have the Hopital rule. And 4, we have the comparison method. And there are many more. So first, we pay reference to the first one, which is the direct substitution. Direct substitution will work here. If you come across any limit question, what should first of all come to your mind is pay reference to the denominator. Now, with this one now, we use the first method known as the direct substitution. Wherever we see x, we replace it by 2. Now, 2 all over 2 squared plus 1 equals 2 all over 2 squared is 4 plus 1 equals 2 all over 4 plus 1 equals 5. 2 divided 5 will give you 0.4. I told you that this is just an introductory part of limit. Limit itself talks about function, the function f of x. As x approaches to, what will be the possible number or value for the function f of x? That's all limit is all about. Okay, let's solve more questions on this limit to get a broader understanding of what we are talking about. Okay, on that limit, these are the possible questions you might see or encounter. Now, question 1, limit f of x when x approaches to equals x all over x squared plus 1. Now, wherever you see x, you should reduce by 2. 2 all over x squared plus 1 plus 2 all over 4 plus 1 equals to 2 all over 5. 2 divided 5 will give you 0.4. That is it. Question 2. Find the limit f of x when x approaches 1. You see, the difference between question 1 and 2 is that direct substitution may not likely work in question 2. Why? Because when you use direct substitution, we will end up having 0 at the denominator. And 0 at the denominator, it's not a factor of limit. It is not a limit. The reason why we use direct substitution at question 1 is because when you use direct substitution, it will not give us 0. So, mind you, say a question like this, you proceed to the next method called factorization method. You have to factor this one to avoid 0 at the denominator. Now, we factorize the numerator, having x plus 1, bracket open and close, bracket open, x minus 1. Mind you that this one is synonymous to this one. We can multiply this one with this one, it give you rise to this one. So, we cancellation method. This one cancel this one because they are like. Now bringing this one out. Remember, as x approaches 1, x approaches 1, x, which is the 1, plus this one will give you 2. Question 3. Find the limit of the function as x approaches 1. Okay, now using direct substitution may work, but it is not advisable, we factorize. We also use factorization method. Factorization method, factorizing the numerator leads us to x plus 1, bracket open and close, x minus 2. Multiplying this one with this one will give rise to this one. That is how it is. Now, we also factorize the denominator. Factorizing the denominator will give us x plus 2, bracket open and close, bracket open, x minus 2. Multiplying this one with this one will give rise to this one. That is it. Now, by cancellation, we cancel like terms. This one, we cancel this one because they are like. Bringing out the remaining 2, x plus 1 all over x plus 2. Remember, as x approaches 1, 1 plus 1 all over 1 plus 2. 1 plus 1 give you 2, 2 plus 1 give you 3. So 2 divided 3 will give us 0.667. Question 4, find the limit f of x as x approaches 0. This, as you can see, this question is different from the others we have been servicing because the difference between this and this is that this is a trick question. This is a trick question. Applying direct repetition, it will give us 0. Direct repetition is not advisable in this case. In this case, we use the Hopital rule. Derivative, remember your derivative. Differentiating cos x will give us minus sin x. Differentiating sin x will give us cos x. Differentiating x will give us 1 equals to sin minus sin bracket over as. Remember, as x approaches 0, sin minus sin 0 plus cos 0. Sin 0 will give us 0, cos 0 will give us 1. So 1 divided 1 will give us 1. That is it. Question 5. Find the limit f of x as x approaches 3. Remember the rule of limit. Limit is a value when the function approaches at the subset gets closer and closer to a particular value. The correct limit just entails, what it entails that as x approaches 3, what is the function of f of x? Now, x squared minus x minus 6 all over x minus 3. Now, direct substitution will know for this one because applying direct substitution, it will give us 0 at the denominator, which is not a factor of limit. We go further to the next method called factorization method as we used earlier. Now, factorizing the numerator, we have x plus 2, x minus 3. Multiplying these two together will give rise to this one. Now, remember our consolidator method, we cancel like terms. This x minus 3, we cancel x minus 3, leaving us with this one. Remember, it's this when x approaches 3. Now, whenever we see x, we replace it by 3. 3 plus 2 will give us 5. That is it. Just pay close attention. Question 6. What is the limit f of x as x approaches 3? This is another trick question. Differentiating. Remember, if as x approaches 0, using direct substitution will lead us to absolutely rubbish. Now, differentiating the trig, sin x, differentiating sin x will give us cos x. Differentiating x will give us 1. X approaches 0. Whenever you see x, we substitute by 0. Cos 0 will give us 1. While x, remember our derivative, x will give us 1. So 1 divided 1 will give us 1. So that is all about limits. Before whenever you see limit question, mainly pay reference to the denominator. If by using direct substitution, it will end up with 0. Go further to other methods. Use other methods like the direct substitution, the factorization method, or the Hopital rule. There's also one called the comparison method, where you compare both sides of the equation. So that is all about limits for this video. Thank you for watching. Please kindly like and press this notification button so that you get more of our video when we upload them. Thank you.